Today we are going to talk about two important quantities. First is a voltage and second is current. Okay. These are very important quantities in every electronic circuits. So let's start with the voltage. Okay. So voltage is measured in volts, and voltage is measured across, or it's always taken in parallel of 2 points. Suppose we have some circuit here and we want to measure a voltage across it, then that voltage is always taken in this way. Okay, so how you define the voltage? Voltage is also known as potential difference, or it is also known as electromotive force. So basically voltage, it's a work done. Okay, voltage is a work done, it's an energy, it's a work done to move a unit positive charge from let's say negative potential to less negative or positive potential. So to explain it in a simple way, consider there is this hill, okay, and there is a positive potential, unit positive charge here, and this is positive potential, while this is this is negative potential, and this is more positive potential. So work is done to move this charge from more negative potential to less negative potential. This unit positive charge is called as voltage. Well, this is not really intentional approach, but voltage is something which is the reason for the flow of current. Okay, it's a cause for current flow through the circuits. We have potential difference, we have voltage in the circuit, that means there will be a current flow. There are different quantities to measure the voltage. It's measured in millivolts, which is 10 raised to minus 3 volt. It's measured in microvolt, which is 10 raised to 10 to the power minus 6 volts. It's measured in nanovolts, which is 10 to the power minus 9 volts. You know, there are different types of ways the voltage can be measured. Let's talk about current. Current is measured in ampere. Generally, ampere is a unit of measure current. Also, it is measured in nanoamperes, milliamperes, microamperes. You know, nanoamp is 10 to the power minus 9 amp, milliamp is 10 to the minus power minus 3 amps, 10 to the power minus 6 amps. Okay, so current is defined as a flow of charge per second per unit time. It's a flow of charge or flow of electrons per unit time. So I, which is denoted by current, I is generally Q by T. Q is a charge per unit time. In a more technical manner, charge is presented as 1 coulomb, and if time is written as 1 second, this gives 1 amps of current, which says that it means 1 coulomb of charge flowing per second. 1 coulomb amount of charge flowing per second. This gives 1 ampere of current. Okay. Always remember that current flows through the system. It will flow through the circuit, or flow, or we can say it past the point. We can say past the point. For example, consider there is some electrical circuit here, X. When the current will flow through that circuit, the current is going to flow like this from here, and it's going to come out from the other end, while the voltage is going to apply to terminal A and B. So we going to apply voltage here across the terminals, while current is through the circuit. Sometimes we say that voltage is measured at a point, or we say that voltage is taken at some point. That is, suppose this is that point where voltage V is measured, so that voltage is measured with respect to ground always. So voltmeter, which is an instrument used to measure the voltage, is connected here. to that point with respect to ground. So we will talk about this in upcoming lectures. So always remember that voltage is measured across the point in parallel to the point, while current is measured through the point. Current flows past a point. There are different kinds of instruments which are used to measure voltage and currents. These instruments are, first instrument is oscilloscope. There are different types of oscilloscopes: mixed signal oscilloscope, digital signal oscilloscope, analog signal oscilloscope, out of which mixed signal oscilloscope is most popularly used in companies. On the oscilloscope is, remember, oscilloscope is a measuring instrument. It's not something which generates the voltage or current, but it measures the voltage or current. There is an instrument called as function generator. This instrument generates power. This instrument will generate voltage / current for you. There are different kinds of instruments. Some instruments are used voltage source, or these are known as DC power supplies. These are used to generate a DC voltage with different range. Again, let's talk about small devices in our everyday life, like battery. Or like we said, right, voltage is always a energy on the charge, right? So its voltage is defined as energy per unit charge. That's the other way to define the voltage. So in the battery, there is a conversion of electrochemical energy into electrical energy, which is nothing but voltage. If you talk about generator, in generator, mechanical energy is converted into voltage or electrical energy. There are solar panels where photovoltaic energy, the photons are converted into electrical energy. So that's how the energy conversion happens. Let's talk quickly about two simple rules in every electronic circuit. The first rule talks about law of conservation of charge, or it is known as Kirchhoff's current law, KCL. It's a Kirchhoff's current law. Some people call it Kirchhoff's, some people say it as Kirchhoff's. Yeah, I say Kirchhoff's. This law says that suppose there is a node in a circuit where different amounts of currents are incoming and outgoing. Okay, so the direction of the arrow is the current direction. There is a current I1 coming into the node A. There is current I2 coming into the node A. Suppose current I3 is going out of the node. Suppose current I4 going out of the node. Then the sum of the current coming and going out of the node is always 0. That means I1 plus I2 plus I3 plus I4 should be 0. That's what it means. So we have taken a magnitude. If we say I1 is 1 amps, I2 is 2 amps, then I3 is minus 2 amps, I4 is minus 1 amps. So 1 plus 2 minus 2 minus 1 is 0. Amount of current coming into the node is equal to amount of current going out of the node, right? Amount of current coming into the node, right, is equal to whatever is the amount of current going out of the node. That's the equation. This is called as law of conservation of charge. Charge is always conserved. Whatever you are gaining, you are giving it back. That's what it means. So it's called as Kirchhoff's current law. That's the first law. Let's talk about the second law, which is regarding a voltage, and it's known as KVL, which is Kirchhoff's voltage law. This law says that if you have a closed circuit, right? Suppose there is one circuit which has different components, component A1, B1, C1. It has all these three components, and each component has some voltage across it. This is V1 across this. We just saw that voltage is taken across the device. Then there is a V2 here, then there is a V3 here. So this law says that in closed loop system or in a closed circuit, okay, circuit needs to be closed at all the ends. The addition of all the voltages in a one direction is zero, or all the voltages, addition of all the voltages or sum of all the voltages across the loop is zero. It has to be done in one direction, so we assume that from we will go in a clockwise direction, plus minus plus minus plus minus, and we will go like this. Okay, so we can say that voltage across A1 plus voltage across B1 plus voltage across C1 should be 0. V1 plus V2 plus V3 is 0. This is a KVL, Kirchhoff's voltage law, which is applicable for every closed loop system, every closed loop circuit, and it states that sum of all the voltages across the loop is always 0. So we learn these two laws, KCL and KVL. Along with this, we learn to measure quantities. We talked about voltages, we talked about currents, how do we denote them, how you measure voltages and currents, what are they actually, we talked about that, and we talked about KVL and KCL in a very brief manner. So that concludes our first lecture. Thank you.